Next, correlation coefficient and correlation test. Uh, it is very useful technique. Okay, if you want to identify the relationships between the two variables. So, uh, especially for the two independent variables, I think correlation coefficient and correlation test will be very useful techniques. So I would like to introduce the Pearson correlation coefficient, which is quite popular. Okay, many researchers use the Pearson correlation coefficient to reflect the level or the strength level of the relationship between the two independent variables. So uh, Pearson correlation coefficient, or in short we call Pearson, R. Okay, R stands for Pearson correlation coefficient. R is defined in statistics as the measurement of the strength of the relationship between two variables and their association with each other. In simple words, Pearson correlation coefficient calculates the effect of change in one variable when the other variable changes. So you can have two type of relationships, but actually three. But for make it simply, okay, let's say positive linear relationship or negative linear relationship. Okay, the case above, positive linear relationship. In most cases, the income of a person increases as the age increases. All right, it's clear. When the age increases, okay, the income increases. But for the negative linear relationships, for example, if the vehicle increase its speed and the time taken to travel decreases, and vice versa, right? Like opposite direction. But from the example above, it is evident that Pearson correlation coefficient R tries to find out two things. The first one, the strength of the relationship from the given sample size. And the second, number two, the direction of the relationship. Okay, you can identify the strength and the direction of the relationship between variables, between two variables. This is the Pearson correlation coefficient formula R. It is equal to n sigma xy minus sigma x times sigma y divided by square root of n sigma x squared minus sigma x squared in the bracket and times another bracket n times sigma xy squared minus sigma y squared. So this is a correlation coefficient formula. So the most important thing is the correlation and coefficient formula finds out the relation between the variables. So it returns the values between -1 and 1, just -1 and 1. Okay, and we measure the strength of the two variables. So when n is a number of pairs of scores, and sigma xy is the sum of products of pair score, and sigma x is the sum of x score, sigma y sum of y score, and sigma x power 2 sum of square x score, and sigma y power 2 the sum of square y score. Okay, this is how to define each variables. Okay, and then I think we have time, 5 minutes. Let's continue. Okay, step one, we create a table like person 1, 2, 3, 4. You have 1, 2, 3, 4, 5 columns: age, x, income, y, x times y, okay, x power 2 and y power 2. Okay, and then you create Pearson correlation coefficient table. We call it, okay, R table. You make a data chart including both the variables. Label these variable x and y, add 3 additional column x, y, okay, x squared and y squared. And then you put the data into the table, okay, and you use basic multiplication to complete the table. You compute x, y, x squared and y squared. Easy. Step 3, you add up all columns from bottom to top, and you create a new row, okay, the last row total, and you sum up, okay, you sum up. Step 4, use the correlation formula to plug in the value, okay, this formula, okay, this formula, okay, to compute R. And if the result is negative, for example, minus 8, minus 0.5, minus 0.8, sorry, minus 0.5, negative, right? Okay, there is a negative correlation relationships between two variables. Very simple. If the result is positive, like 0.05, 0.07, or even 1, there is a positive correlation relationships between the variables. So results can also define the strength of a linear relationship. It means the linear relationships occurs. Okay. It depends upon a strong positive linear relationship, strong positive relationship, or strong negative relationship, weak positive relationship, weak negative relationships, or medium positive relationships, so on. So, how to interpret the Pearson correlation coefficient? Okay, below are the proposed guidelines for the Pearson correlation coefficient interpretation. Okay, you can see the level of strength of association: small, medium, and large. Okay, and you have positive values and negative values. Okay, from 0.1 to 0.3, so small. Minus 0.1 to minus 0.3, negative and small. 0.3 to 0.5, positive and medium. Minus 0.3 to minus 0.5, negative, medium. And 0.5 to 1, large. And minus 0.5 to minus 0.5 to should be minus 1. Okay, large. Yeah, please correct it. Okay, I'd like to stop the video here, and next I'm going to talk about the strength and direction. The strength and direction. I will give you see the graph, the sample